Hello everyone, and in this video we are going to be talking about converting between the measurements of length. So let's get straight into it. So we're going to be looking at 4 different units of measurement, and the ones that we're focusing on in this lesson all relate to length. In other words, these are units of measurement that we use to measure how long something is. Okay, so which units of measurement are they? We have the millimeter, centimeter, meter, and kilometer. 4 units of measurement that we want to really understand today. Okay, so like I said, all of these measurements are involved in measuring how long something is or how tall something is. Okay, what we really need to understand before we go any further is we need to kind of have a good perspective of what a millimeter, a centimeter, a meter, and a kilometer looks like. How long are those things? And that can be quite difficult to imagine, but there are some common exam questions within the 11 plus exam, within the SATS exams, or any maths exam, where you're asked to estimate the size of something, or perhaps you are given a question such as, which of these objects is most likely to be a meter long? And it will give you a list of objects, and you need to pick the one that is most likely to be a meter long. So how are we going to answer those questions? Well, let's first of all improve our understanding of how long each of these measurements are. So we've got 1 millimeter. Now, 1 millimeter is about the width of a pencil lead. So if you look at that pencil lead on the screen, not how tall it is, but how wide it is. It's very thin, isn't it? That's 1 millimeter. Okay, if you put your 2 fingers together, that's about a millimeter. Now, a centimeter, slightly bigger, it's about how wide your fingernail is. Okay, so there's not much in it, but just remember that 1 millimeter is very thin, and 1 centimeter is bigger than a millimeter. Okay, but it's about the width of your fingernail. Now we're going to talk about how millimeters relate to centimeters in a minute, but for now, let's just remember how long these measurements are. So 1 millimeter, width of a pencil, the lead of a pencil. 1 centimeter, how wide your fingernail is. Let's look at 1 meter. 1 meter is about the size of a guitar. Okay, so put a guitar on the floor from bottom to top. 1 meter is about the size of your average guitar. Yes, there are smaller guitars. Yes, there are bigger guitars. But as a nice standard average, picture a guitar when you're picturing 1 meter. And finally, we've got 1 kilometer. 1 kilometer, listen to this one very carefully. 1 kilometer is about the length or the distance of a 10-minute walk. So imagine walking for 10 minutes. Maybe put a marker down where you start. Walk for 10 minutes. Stop. Put another marker down. That's 1 kilometer. Okay, so why a large distance? Okay, all right. So the question at the top is one of those questions that I was talking about earlier. Is asking us to do a little bit of estimating. Okay, so it says which of these is most likely to measure 50 centimeters in length? Most likely. Okay, so if we want to know what 50 centimeters in length feels like, what it looks like, well, we can see on the screen here that 10 millimeters equals 1 centimeter. Okay, so there are 10 millimeters in a centimeter. In other words, 10 widths of a pencil lead is about the size of the width of a fingernail. Okay, and then 100 centimeters is the size of a meter, is the same as a meter. Okay, in other words, 100, if you think of fingernails, if you place 100 fingernails, which isn't a nice thought, but if you place 100 fingernails side by side, 100 of them is a meter. Okay, about the size of a guitar. And then there are 1,000 meters in a kilometer. Okay, so 1,000 guitars stand on top of each other is 1 kilometer. Okay, so the 2 things I want you to remember so far is 1 millimeter is the same as the width of a pencil lead. 1 centimeter is the same as a fingernail. 1 meter is about the size of a guitar. And 1 kilometer is about the distance of a 10-minute walk. The next thing I want you to remember is there are 10 millimeters in a centimeter. There are 100 centimeters in a meter. And there are 1,000 meters in a kilometer. Try to remember those 2 things, okay? Now, what I'd like to do is pause the video if you need to and have a think about what we've spoken about so far. If you're really confident and you can remember those two things we've just spoken about, then keep watching. Otherwise, pause the video, maybe rewind, and have a think about what we've spoken about so far. Make sure you remember it, okay? So I'm going to test you. If you're watching this bit here, it means you should be able to answer the following questions. If you can't answer the following questions, then I'd like you to maybe rewind and watch again, or get someone to help you, okay? So first thing I want you to answer is name something that is about 1 millimeter in length. And now name the thing that I showed you in this video. What is the thing in this video that is about 1 millimeter in length? 3, 2, 1. The answer is pencil. Tip. The tip of a pencil, the lead of a pencil. Okay. Next question is name something that is about 10 millimeters in length. Oops, 10 millimeters in length, or 1 centimeter. They mean the same thing, remember? Okay, so can you name it? What was this thing? What was the thing in this video that is 1 centimeter or 10 millimeters in length? 3, 2, 1. The answer is I apologize for the typing today. The width of a fingernail. Okay, next question. Can you name something that is about 1 meter or 100 centimeters in length? So remember, 1 meter is the same as 100 centimeters. What is it in this video that is about 1 meter long or tall? 3, 2, 1. The answer is guitar. And finally, name something that is about 1 kilometer or 1,000 meters in length. 3, 2, 1. Of course, it's a distance of a 10-minute walk. Okay, so next thing I want to ask you before we continue is how many millimeters in a centimeter? How many centimeters in a meter? How many meters in a kilometer? So I've abbreviated all of our units of measurements: millimeter, centimeter, meter, and kilometer. Okay, and that's quite important to understand. We want to be able to express these units of measurement using these abbreviations. Okay, so first question: how many millimeters in a centimeter? The answer is 10. How many centimeters in a meter? The answer is 100. Oops, 100. How many meters in a kilometer? The answer is 1,000. If you understand everything so far, great. Let's keep going. If you don't, maybe rewind, watch again, really try to take it in, because things get a little bit more tricky as lesson involving lengths go on. Okay, what we don't want to do is keep watching if we're already confused, because we're going to confuse ourselves further. So make sure you fully understand everything to this point before moving on. If you do understand, let's move on. So the next thing I want to talk about with you is this question: which of these is most likely to measure 50 centimeters in length? Is it a cat? Is it a staple? Is it a teenager? Or is it a very short jog? Let's do some deductions. Remember what deductions are? Let's rule out the answers that we know it isn't. Okay, so for example, firstly, let's measure 50 centimeters in our head. Let's think about, what does 50 centimeters look like? Now, we know the guitar is 1 meter or 100 centimeters. 50 centimeters is half of 100 centimeters. So we're talking about half the size of a guitar. Yeah. So think of a guitar in your head and think about what is roughly half the size of a guitar. And we know that could a cat be half the size of a guitar? It sounds like it could be, but before we select a cat for sure, let's look at the others to make sure, okay, that we're not getting confused. So a staple, is a staple about the size of half the size of a guitar? No, a staple is tiny. So let's get rid of a staple. What about a teenager? Is a teenager about half the size of a guitar? Of course not. A teenager is usually much taller than a guitar. Yeah. And then finally, we've got a very short jog. Okay. Think about someone jogging. Even if it's a very short jog, is it likely to be half the size of a guitar? Well, perhaps my jogs might be. I don't jog for very long. I try to. But the average person, if they were to go for a short jog, would they be traveling for a distance longer, than half the size of a guitar? Of course they would. Imagine jogging for less than half the size of a guitar. Yeah. we wouldn't be jogging for very, very long. So we know it's not that one. So yes, cat is correct. Now, what I did there was very important. I thought the answer was cat, but I just checked the others just to make sure. Okay, it's very important we do that in case we get a bit confused. So that's the first question. I've got one more of these questions I'd like you to have a go at, all by yourself. Which of these is most likely to measure 1 kilometer in length? So if you need to, pause the video, look at the question, have a go at this, play the video, and see if you're correct. Okay, if you're watching me speak at this point, it means that you have an answer to this question. Which of these is most likely to measure 1 kilometer in length? Okay, let's do some deductions again. Now, we know a 1 kilometer in length is about the size of a 10-minute walk. Okay, so it's quite a long distance. So I know that there is no human being in the world that if they were to be lying down on the floor, imagine walking for 10 minutes and not being able to get from the bottom of that human to the top of the human. It wouldn't happen, okay? No human, even the tallest human, can be longer than a distance of a 10-minute walk, no? So let's get rid of that one. Oops. Okay. Same thing can be said about a crocodile, yeah? A crocodile, they can be quite long, but it wouldn't take you 10 minutes to walk from the top end of a crocodile to the bottom end of a crocodile. Not least because they might eat you. All right, 2 more options. Which of these is most likely to measure 1 kilometer in length? Football pitch, seafront. Okay, so if you're a bit confused here, if you are having trouble picking between these two, I can see why, but let's think about this as logically as possible. Think about being next to a football pitch. Think about being one end of a football pitch. Think about walking non-stop for 10 minutes. I think you would get to the end of a football pitch. In fact, I know you'd get to the end of a football pitch, okay? It doesn't take footballers 10 minutes to get from one end of the pitch to another end of the pitch. I know they might be jogging, they might be running, but think about them walking. It would not take them 10 minutes, okay? So this one requires a bit more sort of perspective of time, okay? So if you know how long 10 minutes is, this is going to help us answer this question, okay? So of course, the football pitch, it will take us quite a bit less than 10 minutes to walk the length of a football pitch. So the most reasonable answer here is the seafront. And you might say, well, I know this seafront, which is very, 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 very short. You might say, I know a seafront that goes on for miles and miles and miles and miles, and you could never do it in 10 minutes. And of course, you'd be correct. However, we can rule out the others, but we can't rule out that some seafronts might be about 1 kilometer in length. Okay, so the most likely, remember, is the question. The most likely is the seafront. Okay, so well done if you said that. So like I said at the beginning of this video, these questions that we just spoke about are quite common where we're being asked to think about what the most likely measurement of an object is. Now look out for my video on mass and capacity, because we'll be doing the same sort of questions with how heavy things are and questions relating to capacity as well. So make sure you look out for those videos. But before we get to the end of this video, we need to talk about converting. Okay, converting. Now, this is a place value grid. Hopefully we know what one of these are. If we don't, let's just quickly talk about them for about 1 minute, okay? Think of any number, 47, 325, I don't know, 1,496. Let's think of some decimal numbers, 5.4, 1.25. Okay, I've just thought of 5 random numbers, okay? And what I want to do is put these into my place value grid. So we've got 47, yeah? How would I put this into the place value grid? Well, we know that 47 is made up of 4 10s and 7 1s. So let's change the pen color. So 47 is 4 10s and 7 1s. Okay, 325 is made up of 3 100s, 2 10s, and 5 1s. What about the next one? See if you can say it before me. Where would we put 1,496? Of course, we've got 1 in the thousands, 4 in the hundreds, 9 in the tens, and 6 in the ones. Let me move these out of the way. Okay, we've got 5.4. All right, this is where some people start to get a bit confused. So 5.4, let's forget the decimal for a minute. We've got the number 5, haven't we? And we know the 5 is just a ones digit, okay? So 5 would go in the ones, Then I've got my decimal point 4. Look at the place value grid. We've got the decimal point here, which isn't a place. We can't put anything inside there. So we've got 5 decimal point 4. 4 is the next digit along. So it's a tenth. So 5.4. And then we've got 1.25. Once again, let's get rid of the decimal places. Forget they exist. We've got number 1, which we know is just a 1. So we've got 1, 1. So we put the 1 in our ones. And then we've got decimal point 25. Decimal point 25. So it's 2 tenths and 5 hundredths. Okay. So I know I sped through that explanation of a place value grid. If you don't understand it, you must do some research. There are plenty of videos on place value. Okay. But that's not what we're really talking about too much today. But make sure you understand that. Hopefully you do understand that, because we're going to move on now where understanding that is going to be important. So this is what we call a conversion table. And this is how we get from different units of measurement. In other words, if you're asked to change or convert between, I don't know, 50 centimeters into meters, we can use this table to do that. How does it work? It looks daunting, it looks confusing, but it's not, I promise you. What's this? Okay. Here are some questions. I am told that a child is 120 centimeters, right? But in the millimeter box, it's empty. And in the meter box, it's empty, right? So I need to fill in those 2 boxes. I need to find out what a child is in millimeters and what a child measures in meters based on the fact that the child measures 120 centimeters. How do I do this? Okay, watch very carefully. I'm going to talk slowly here, okay? So if I want to go from centimeters to meters, in other words, if I want to change from centimeters to millimeters, I need to look at my conversion table and find out, where does it say cm to mm? Is it up here? Is that the one? No, that's not the one, because this one says mm to, the arrow is pointing towards cm, mm to cm. We want to go from cm to mm. So we want cm with an arrow pointing to mm. And if you look beneath that, it's there. Centimeters to millimeters. If I want to go from centimeters to millimeters, I'm looking at this bottom section here. Okay, so let's get rid of all that. We are looking at this arrow. Now, what does this mean? I'm looking at it, but what do I do with it? Well, because it's at the bottom, yeah, because it's at the bottom of the of this table, it means I need to do the bottom operation. I need to multiply. I need to multiply by the number that comes between them, which is 10. There are 10 millimeters in a centimeter. Look, 10 comes between mm and cm. So 10 is the important number. Multiply is the important operation. I need to multiply by 10. So 120 multiplied by 10 gives me the answer. How do I do that? Well, you might be able to do 120 times 10 in your head, okay? If you can't, let's put it in the place value grid. 120 has 100, 2 tens, 0 ones, okay? Now, when we multiply using the place value grid, we always move our digits to the left. They get bigger. Hundreds become thousands, tens become hundreds, ones become tens. They get wider and bigger. So we're moving to the left. We're expanding the number, okay? We move to the left. And also this arrow suggests that we move to the left as well. So we move to the left. Now, if we multiply by 10, we move to the left once. And a good trick is to look how many zeros the number has. 10 has 1 0. 1 0. So we move to the left once, okay? So all of these digits are being moved to the left once. So once, once, once. But we've got a problem here. We've got no ones. How can we have a number that has thousands but doesn't have any ones? Well, let's show that it has no ones. This number has 0 ones. Let's put the 0 here. And we've got our answer, 1,200. Okay, so that is the answer. Now I'm going to do one more and the rest is up to you. So this time I want to answer the next question. So I want to go from centimeters to meters. Okay, so let's look at the table, this table up here. Can you see, where does it say centimeters into meters? Where does it say centimeter, arrow, meter? If you said here, not quite. This doesn't say centimeters into meters. This says meters into centimeters, okay? If we look above it, centimeters into, arrow, meters. So we're looking at the top one, okay? So let's get rid of that. Now that we know where we're looking, let's look at the operation and the number. The operation this time is divide, because we are looking at the top of this, this table. And we're dividing by 100, because 100 comes between centimeters and meters. There are 100 centimeters in a meter, okay? So we get our number 120. And to change it into meters, we are dividing by 100. We're divided by 100. So if we go to the left when we multiply, what do we do when we divide? Of course, we go to the right. Our number is getting smaller. We're dividing our number. It's getting smaller, okay? So it's not getting wider. It's shrinking. So our numbers need to go to the right. Our hundreds are becoming tens, and our tens are becoming ones, and our ones are becoming tenths, okay? So we are dividing. We're moving to the right, and also these arrows remind us that we're going to the right. Okay, so we're divided by 100. How many zeros does 100 have? It has 1, 2, 2 zeros, yeah? So we're going to the right. We're going to the right twice. Let's move these digits to the right twice. So 1, 2, 1, 2, 1, 2. And look, I've got an answer. The answer is 1.20 or 1.2. Okay, 1.2, 1.20 mean the same thing. We've got 0 hundredths. We don't need to express them. 1.2. Yeah. So the answer is 1.2 meters. The child measures 1.2 meters. Okay, so if you're a little bit confused by this, I do understand. It can be tricky at first, but practice, 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 practice. And then the more you practice, the easier it will become, okay? Now, the good news is when we are converting between other types of measurement, like mass and capacity, this is easier because we're not going from we're not using 4 different units of measurement. We are using 2. With mass, we're using grams and kilograms. With capacity, we're using milliliters and liters. With length, we're using millimeters, centimeters, meters, and kilometers. So this is the trickiest one. So if you can do this, the next videos involving measurement are going to be a bit easier. Okay. So as usual, there will be a worksheet based on this learning. The worksheet will include 2 tables. It will include this table that you can see at the bottom of your screen. Can you finish it off? I did the first 2. Can you complete the rest? And then once you've done that, on the worksheet, there is another table. I don't know if I've put it up. No, I haven't put it here. But on the worksheet, in the link, in the description of this video, on the worksheet, there is another table for us to complete. So it's 2 tables. Okay. Thank you very much for watching, guys. Bye.